do it, there's a classical method of attack for these two, which I tend to ignore, but I love the fact you're doing it right now. This is perfect. It's clearly back here. Because this one is at 3.2%. What's the one that gets us 95%? Well, if we go to the machines, and I run my program again, and this is one of those things, don't worry about this program. I'll give it to you if you want it, but you don't need it for this class in general. More probabilities, thank you. Let's do a backwards problem. Left, shading 5%. Okay, here he comes. Negative 1.64. If you sneak past negative 1.64, that means you're in the significant region. So, in other words, this would be your confidence interval, Aaron. Thank you very much. If you wanted a one-sided confidence interval, you now have it with this value. You take, and Sean, this goes back to what we talked about on Thursday as well. You now have 95% confidence there. 1.64, negative 1.64. You could reverse engineer from this calculation to figure out what percentage that would be equal to. I'm guessing it's somewhere around, I don't know, 10.5, 10.6%. Nah, probably not even that, 10.3%, something like that. Which is not that much of a difference, is it? 10.3 versus 10.1% is not that much. That's 2 people in your sample, right? Of a size 1,000. So, is anybody bothered by the fact that, okay, I buy the fact that it's mathematically significant. Brian, if I answered your question first, you have more question to go.
No.
Are you sure?
No, keep going.
I want to make sure that, okay, so is anybody sitting there going, okay, I'm going to do it, props. I get that it's mathematically significant, right? I understand the statistics of the significance because you have established a confidence interval and your sample data is outside that interval. So I get that it's statistically significant. I just don't think that it's practically significant. I don't think personally, everybody thinking this? I don't think personally that dropping the flu rate by 2% or 1.9% is practically significant. Is anybody, raise your hand if you're thinking that right now. Guess what? I got no contest for that statement because I can't contest practicality. I can only talk pure statistics. Practicality becomes a contextual thing. Is a 1.9% drop in flu rate practically significant? I don't know.
It's up to the audience.
It's up to the audience. I can't discuss practicality of results in this class. All I can talk about in this class is statistically significant, not practically significant.
Yeah, but if you base it on 1,000 people, it's not that significant. But if you base it on...
But it is.
If you base it on...
Mathematically it is.
Well, yeah, but you're saying if you base it on the entire population, then it is significant.
Thank you, Chris. Now I want to go with this statement again. If in the general population, let's forget statistics for a second and play the parameter game. Let's suppose in the actual population, the flu rate is 12%. That's for those not inoculated. And for those that are inoculated, in the population, the flu rate is 10%. Is that less? Of course it is. It's 2% less. The statistics can't measure whether or not you perceive 2% as meaningful. But it is mathematically less. That's the only tool we have at our disposal in this class for the next 5 weeks is can we show statistical, this is such an important point. I'm really glad you guys brought this up. It's not whether we believe 1.9% is meaningful. It's whether we can conclude that 1.9% is statistically significantly different. And do you see the difference there? This is when we start sounding like cold-hearted computers. It's statistically significant. Yes, but it's statistically significant. But that's all you can do. There's no wiggle room around statistical significance. Brian, you have given us a line in the sand at negative 1.64. If we get past that, unless we made a type 1 error, there's a statistically significant difference. Thank you for that. Other questions on that before I get Elizabeth's question? Are you guys okay with what Brian asked? I love that you asked that. Thank you, sir. We good? Ish? We good-ish? We good-er? Elizabeth, go.
I'm a little confused about the 3.22.
Oh, that is the probability. You know what that is? Let's put it on the sideboard over here. Okay? That's the p-value.